Welcome to the deep dive. Today we're getting into the nuts and bolts of building enterprise-grade Node.js applications.
Right.
We've looked at a lot of material, really trying to boil it down to the critical technical know-how you need. We're talking scalability, performance, reliability, the big challenges in large organizations.
Absolutely.
Our goal here is to give you a solid, practical understanding, whether you're new to Node in this context or pretty experienced.
Yeah, hopefully something for everyone.
So the mission for this deep dive, to really nail down the core technical knowledge, you need to understand and build those robust Node.js apps for the enterprise world.
Okay, sounds good. Where should we start? Maybe with the challenges.
Good idea. What happens when these Node apps start getting really big inside a company?
Well, that's where things get interesting, technically speaking. As they scale, you immediately run into some inherent challenges.
Like what specifically?
First off, you really need efficient event-driven architectures. That becomes paramount for handling the increased load.
Right, managing all those events.
Exactly. And tied very closely to that is proper concurrency management. You absolutely have to get that right, technically, to keep things stable and performing well.
Okay, concurrency. Makes sense. What else?
Then there's security. In an enterprise setting, robust technical security practices aren't optional, they're fundamental.
Non-negotiable.
Precisely. And finally, just raw performance under heavy load. That's a baseline technical requirement you have to meet.
Okay, let's unpack those scaling challenges a bit more. Our sources mention teams hitting technical hurdles, especially maybe with less experienced Node engineers.
Yeah, that comes up a lot. You see things like inefficient coding patterns creeping in.
Like blocking code where it shouldn't be.
Exactly. Over-relying on synchronous operations when async would be much better, or introducing performance bottlenecks without realizing it.
So what kind of technical expertise becomes, well, indispensable when you're dealing with these bigger, more complex distributed systems?
Well, debugging changes dramatically. When you move to distributed systems, tracing an issue across multiple services is a whole different ballgame than debugging a monolith.
Right, you need different tools, a different mindset.
Totally. And you absolutely need a deep, granular understanding of the Node.js event loop. That's critical for finding those performance bottlenecks that just get amplified at scale.
And memory management.
Oh, absolutely crucial. Memory management becomes much more vital to prevent resource exhaustion and keep all those instances stable.
It's clear that building for enterprise needs a different technical gear. So what is it about Node's core architecture that makes it suitable for these demanding environments anyway?
It really comes down to its fundamental design. It's lightweight, it's event-driven, and critically, it has that non-blocking I/O model.
Okay, non-blocking I/O. Let's dig into that.
Right. That model inherently makes it super efficient for I/O-heavy tasks. Think web apps serving tons of users, APIs handling loads of requests, microservices constantly talking to each other.
So it doesn't get stuck waiting.
Essentially, yes. The non-blocking I/O means a single node thread can juggle thousands of concurrent connections without getting bogged down waiting for, say, a database query to return. It just moves on to the next task.
And that translates to?
It translates to significant scalability and efficiency. Often, you see real benefits in infrastructure costs compared to older, more resource-hungry technologies like, traditional Java or .NET stacks in some scenarios.
Okay, handling high traffic is one thing. What about the development process itself? Any technical advantages there for enterprise teams using Node?
A big one is using JavaScript across the full stack.
Right, client, server.
Client, server, even databases sometimes with NoSQL. That uniformity really streamlines the workflow. Developers aren't constantly context switching between languages.
Reduces cognitive load, as they say.
Exactly, and it lets organizations leverage their existing JavaScript talent. Plus, Node really encourages modularity.
Building reusable components.
Yes, which is essential for building and maintaining large, complex applications efficiently. And of course, there's NPM.
The package manager. Huge ecosystem.
Massive. Access to this vast repository of open source modules just accelerates development like crazy. Boosts reliability, too, often.
Our sources really stress how much Node has evolved. It's not just for small scripts anymore.
Not at all. It might have started simpler, but the continuous development, the community contributions, it's really matured into a robust, dependable framework. It can absolutely handle demanding production-grade enterprise apps now.
The download numbers seem to back that up.
They do. It shows widespread adoption and, frankly, trust from a huge developer community.
Okay, another critical technical point for enterprise. Maintenance. The materials really hammered home keeping Node.js itself up to date. Why is that so crucial technically?
It's fundamentally about security. Simple as that.
Not just new features.
Features are nice, but security is paramount. Older Node versions eventually hit end of life. No more security patches.
Leaving you vulnerable.
Exactly. Vulnerable to known exploits. The good news is, updating Node is usually technically quite straightforward.
And the LTS schedule helps there.
Yeah, the long-term support schedule provides stability. Predictable releases with extended support windows, which is perfect for enterprise planning.
The open source nature of Node often comes up as a plus. What are the concrete technical benefits for an enterprise using an open source platform like this?
Several key technical advantages, actually. You can directly engage with the platform's development.
Contribute back, fix bugs.
Right. Report bugs, contribute code, maybe even influence the roadmap based on your company's specific needs, rather than just waiting on a commercial vendor.
More control, in a way.
And it fosters long-term sustainability. It's a collective effort, transparent governance. Participating, submitting patches, improving docs, even sponsoring maintainers helps keep the platform stable, secure, and innovative, which is good for everyone relying on it.
Let's move from theory to practice. The sources gave some great examples of big companies using Node technically.
Yeah, those really show its versatility and robustness in demanding industries, like American Express in financial services.
What are they using it for?
Data-heavy stuff. Online banking platforms, complex fraud detection, real-time analytics.
Vehicle commerce.
Walmart's a big one. They've built highly responsive, dynamic platforms handling massive traffic, personalization. Node powers a lot of that.
Impressive scale media.
Netflix. They use Node for high-performance backends, smooth streaming, fast content delivery, managing huge numbers of concurrent requests efficiently.
And even logistics.
Right, Uber. Think real-time location tracking, route optimization, matching riders and drivers, all needing fast, efficient information exchange. Node is great for that kind of real-time system.
Those are definitely compelling technical use cases. So if an enterprise is thinking about bringing Node into their stack, what are the key technical considerations the sources highlight?
Well, beyond just the tech itself, you've got to look inward. Assess your team's technical readiness.
Skills gaps, training needs.
Exactly. Then you need to really evaluate the performance and security implications within your specific context, your infrastructure.
It's not one size fits all.
Definitely not. You need to carefully plan the technical integration with existing systems, which can be complex. And crucially, set up solid monitoring and support from day one.
Okay, let's say a technical team is ready to get started. What are the absolute basic first technical steps for setting up a Node environment based on the materials?
It's pretty straightforward, technically. First step, head to the official Node.js website, grab the LTS version, long-term support, the recommended one.
Download and install.
Then verify it. Open your terminal, type Node version and NPM version. Just make sure they're installed correctly.
Okay, Node and NPM are there. What about starting a project?
Standard practice. Create a project directory, mkdir my project, change into it, cd my project, then run npm and it pass what?
The MIOI just accepts the defaults.
Yeah, creates a package.json file quickly. Then if you want to use modern JavaScript modules, ESM, you'll likely want to add type.module to that package.json.
Got it. And then a basic server.
The classic hello world web server. Create a file, maybe server.js, use the built-in HTTP module to create a simple server that listens on a port, like 3000.
And run it.
Just node server.js in the terminal. Then you open your browser to http://localhost.3000, and you should see whatever your server sends back. Basic, but it's the starting point.
The sources also brought up Platformatic, especially for complex projects, maybe involving legacy systems. How does that help technically?
Right, Platformatic is interesting, particularly when you're using something like the Strangler pattern to migrate off old systems.
Gradually replacing parts of the legacy app.
Exactly. Platformatic technically simplifies this by helping integrate the old and new services. It can do things like automatically manage and refresh API schemas between them, detect conflicts, and help maintain loose coupling.
Does it support things like OpenAPI?
Often, yes. Built-in support for standards like OpenAPI or GraphQL makes that integration technically much smoother, reduces a lot of manual plumbing work.
Okay, shifting to specific tech within the ecosystem, Fastify came up a lot as a high-performance framework. What makes it suitable for enterprise technically?
Fastify's big draw is its focus on speed and architectural flexibility. It's really built for performance from the ground up.
What kind of features does it offer?
A lot of things you need for serious APIs. Very efficient data validation using AGV under the hood, good integration with the built-in Node.test runner, solid config handling, graceful shutdown mechanisms.
Graceful shutdown is important.
Crucial. Plus, it bundles a high-performance HTTP client, Undici, and has great database integration support and first-class TypeScript support, often via Typebox. All contribute to building scalable, type-safe enterprise apps.
Testing is obviously vital. The source is detailed using the built-in Node.test module, especially with Fastify. What's the technical workflow there?
Right, testing is non-negotiable technically. Node.test gives you a standard way to write unit tests, integration tests, even end-to-end tests.
How you set it up?
Usually you create a test folder. Name your test files something like .test.js or .spec.js. There are common conventions. Then you run them with node test.
And for testing Fastify routes specifically.
Fastify has a really handy inject method. It lets you simulate HTTP requests directly to your route handlers without starting a full server. Great for fast unit tests.
So you can test a single route in isolation.
Exactly. You can check if it returns the right personalized greeting, if it fetches user data correctly, or importantly, if it handles errors properly, like when a required parameter is missing.
What about end-to-end tests, validating the whole flow?
E2E tests are about simulating real user journeys. So technically, you often want an environment that's close to production.
Like a separate test database.
Yeah, definitely a separate database. Maybe using Docker to spin up dependencies ensures consistency. The sources showed an example. Sign up a user, then try to fetch their profile testing, that whole multi-step workflow using node.test to make the actual HTTP calls to your running app instance.
Performance testing came up again.
Yeah.
Simple timing isn't enough, right?
Definitely not for enterprise load. Basic timing in dev tells you very little about real-world behavior. You absolutely need proper load testing tools.
What do those tools measure?
They simulate many concurrent users hitting your application. They measure key metrics, throughput, how many requests per second, latency, how long each request takes, and error rates. That gives you actionable data on how your app handles pressure and where the bottlenecks really are.
Okay, let's switch gears to configuration. Environment variables are critical technically, especially for security and production. What are the best practices?
Absolutely critical. The main goal is keeping secrets, API keys, database passwords out of your code base. Environment variables are key for that, and also for deploying the same code to different environments, dev, staging, prod, with different settings.
So how do you manage secrets in production securely?
The strong recommendation is to use dedicated secret management services. Things like AWS Secrets Manager, Azure Key Vault, Google Cloud Secret Manager, or HashiCorp Vault.
And avoid .env files in production.
Yes, definitely avoid .env files directly in production. Too easy for them to leak. Also, it's good practice to have a specific variable beyond just no DNV to clearly define the environment and use a hierarchical setup defaults that can be overridden by environment-specific values.
Makes sense. How about graceful shutdowns? Making sure the server stops cleanly. What are the technical approaches?
You need mechanisms to handle termination signals like SIGINT or SIGTERM properly. Libraries like Close with Grace are designed for this.
What do they actually do?
They listen for those signals and give your application a chance to clean up before exiting. You need to manage any ongoing asynchronous tasks, maybe wrap them in promises, set timeouts.
Like closing database connections.
Exactly. That's a classic example. You want to ensure connections are closed cleanly to avoid data issues or resource leaks before the process fully stops.
For making requests out from Node, Undici was mentioned. What's special about it technically?
Undici is presented as a modern, high-performance HTTP client. Its main selling points are speed, low memory usage, and a clean, promise-based API. Plus, it's now part of Node.js core.
It was well supported.
Very. The sources show how to use it for basic GBE requests, but also for more complex things, different HTTP methods, custom headers, setting timeouts. It integrates well with Fastify, too, and has features like interceptors for things like automatic retries or logging.
Databases are obviously fundamental. The sources covered both SQL and NoSQL examples. What are the technical keys for connecting?
The key thing in Node is that database operations are almost always asynchronous. You can't block the event loop waiting for a query.
So for SQL, like PostgreSQL with the PG library.
Right. Technically, you need to configure the connection details, URL, user, password, ideally from environment variables. Then you typically set up a connection pool for efficiency, and all your queries need to be handled asynchronously using promises or async await.
And for NoSQL, like MongoDB.
Similar principles. Configure the connection URI, again, securely. Connect the client asynchronously and perform your operations, find, insert, update using async patterns.
What about ORMs or query builders?
Yeah, tools like Prisma, an ORM, or Next, a query builder, provide an abstraction layer. They can make database interactions technically simpler, more type-safe, and often more maintainable than writing raw SQL or NoSQL queries.
And integrating these with Fastify.
Frameworks like Fastify often have plugin systems or decorators to make database connections available throughout your application, for instance, attached to the request object. And connection pooling is vital for performance reusing connections instead of creating new ones constantly.
Error handling and logging, always critical for stable apps. What technical implementation details do the sources cover?
Super critical. For error handling, Fastify lets you set up centralized error handlers, SEP error handler, to catch unhandled exceptions. You can also have specific error handlers per route.
And logging. Fastify uses Pinot.
Yeah, Pinot is the default, and it's very fast and structured. You can configure it, use middleware to automatically log request response details. A key technical point is structured logging. Logging JSON objects makes logs much easier to parse and analyze later.
Differentiating user messages from developer logs.
Absolutely. User-facing errors should be generic. Something went wrong. Don't leak internal details. Developer logs need to be detailed for debugging. And often you'll integrate with external services like Sentry, Datadog, or LogDNA for aggregation, monitoring, and alerting.
TypeScript's adoption in Node is growing fast. What technical benefits does it bring to enterprise development, according to the guide?
Several big ones. Static typing catches errors before runtime, which improves code quality and reduces bugs.
Makes refactoring safer.
Much safer. It enhances maintainability because types act as documentation and enforce contracts. Collaboration gets easier, too.
How do you set it up with Fastify?
Usually involves installing TypeScript and type definitions at typesnode, etc., setting up a tsconfig.json file to configure the compiler. The sources showed examples of using interfaces for type-safe configuration and environment variables, and using type guards like instance of for safer error handling.
The sources also mentioned Typebox for validation and type safety together. How does that work technically?
Typebox is neat. It lets you define schemas using code that looks very much like TypeScript types. These schemas then work for both runtime validation using EdgeV, which Fastify uses, and generating static TypeScript types.
So validation and type stay in sync.
Exactly. You define it once, you get runtime checks for incoming data, like request bodies, and static type checking in your editor and during compilation. It simplifies testing validation logic, too.
Let's talk integration testing again. How do you technically test interactions with external services using Fastify and Node.test?
Often, you don't want your tests to actually hit live external APIs. It makes tests slow, brittle, and potentially costly.
So you mock them.
Right. Undici, the HTTP client, has a mock agent that's perfect for this. Within your Node.test suite, you can use the mock agent to intercept outgoing HTTP requests to specific URLs and define mock responses.
Like pretending an external user API returns specific data.
Precisely. You tell the mock agent, when the code tries to get this URL, return this specific JSON. This lets you test your application's logic for handling that external data reliably without the external dependency.
Data validation, again, EdgeV was highlighted for performance. Why is it technically advantageous?
EdgeV is known for being a very fast JSON schema validator. Using JSON schema itself is a benefit. It's a standard, good for documentation, tooling support. EdgeV just implements that standard very efficiently.
Perfect for high-throughput APIs.
Exactly. And its integration with tools like Typebox means you get that performance plus the benefits of pipe safety, ensuring your API contracts are solid both at runtime and development time.
Server-side rendering, SSR, is important for some apps. The sources gave a technical overview of Next.js for this. What are its core technical benefits?
Next.js is essentially a full framework built on Node for React applications, heavily focused on simplifying SSR.
Why do SSR technically?
Main reasons are better initial load performance for the user, they see content faster, and improved SEO. Search engines can crawl the server-rendered HTML easily.
And Next.js makes this easier how?
Through features like file system-based routing, automatic code splitting, and special data fetching functions like get server-side props that run on the server before the page is sent to the browser. It also supports static site generation, SSG, and incremental static regeneration, ISR, for different performance trade-offs.
Deployment getting the app running in production, what technical aspects were discussed?
Different strategies. Platforms as a service like Vercel from the creators of Next.js or AWS Amplify offer streamlined workflows, auto-scaling, CI/CD built in.
Easier, but maybe less control.
Potentially. Then there's traditional self-hosting on servers or VMs. More control, but more technical responsibility configuring web servers like Nginx, load balancers, caching headers, revalidation strategies.
Anything for serverless.
OpenNext was mentioned as a tool to help adapt Next.js apps for serverless platforms like AWS Lambda.
Caching strategies are vital for performance. What technical mechanisms were outlined?
Several layers. Standard browser HTTP caching using cache control and E-tag headers is fundamental.
On the server.
For Next.js, static generation, SSG, and incremental static regeneration, ISR, are powerful server-side caching techniques. On the client side, libraries like SWR or React Query help cache data fetched from APIs in the browser. And server-side in-memory caching can provide near-instant data access for frequently needed information.
Security always a top technical concern. Any specific points highlighted?
Yes, things like setting security headers like content security policy, strict transport security in your HTTP responses are crucial. Enforcing HTTPS using secure cookie attributes, and implementing rate limiting, often using something like Redis, to protect your APIs from abuse or denial of service attacks.
Okay, finally, the sources went deep on configuration management, best practices, and modular architecture. Can you summarize the key technical takeaways there?
For configuration, technically, it's about securely managing settings across environments. Use environment variables, avoid hard-coding secrets, use dedicated secret managers like AWS Secrets Manager, Vault, and handle that initial secret zero problem carefully. Consider validation libraries like Zod for config integrity.
And modular architecture.
Technically, the benefits are huge. Encapsulation, reusability, maintainability, testability, easier team collaboration. Understand module systems, common JS versus ESM. Avoid the singleton anti-pattern. It creates hidden dependencies and testing nightmares. Use dependency injection instead, pass dependencies explicitly.
How should you structure the code?
Organize code into logical modules, often by feature or technical concern, maybe folders like lib, plugins, routes. A one-module, one-feature approach often works well for keeping things clean and maintainable in large enterprise apps.
That was incredibly thorough. So if we had to summarize the absolute core technical principles for building enterprise-grade Node.js apps based on all that.
It really boils down to focusing intensely on scalability, performance, resilience, and maintainability.
Through which technical means?
Through mastering asynchronous programming, embracing modular architecture, rigorous automated testing, robust and secure configuration management, and really truly understanding the Node.js event loop.
And choosing the right tools for the job.
Absolutely. The specific tools Fastify, Next.js, Platformatic, your choice of database or monitoring stack should align with your project's specific technical needs and your team's expertise.
For listeners wanting to dig deeper into these technical areas.
Well, we touched on a lot. Fastify, Next.js, Kubernetes implicitly for scaling, Platformatic, Undici, Pinot, Node.test, Typebox, AJV, various monitoring tools. Definitely explore the ones that seem most relevant to your technical challenges or interests. The documentation for these projects is usually excellent.
Great advice. So, to leave our listeners with something to think about. Considering how Node.js keeps evolving and embedding itself deeper into critical enterprise systems, what emerging technical patterns or perhaps future challenges do you think developers really need to get ahead of to build the next generation of truly advanced, dependable applications on this platform?